All right, let's get started. Welcome to Mask at IETF 117 in somewhat sunny and cold San Francisco. Most people know this by now, but make sure that if you are here in person, you scan the QR code over there on the screen, and that puts your name on the blue sheets and allows you to join the queue. If you'd like to speak, you need to be in the queue. If you're remote, you're on MeetEcho already if you're listening to this, and there's a little button that you can click to join the queue. If you want to leave the queue, click the same button again. And similarly, when it's your turn to speak, click the button to send some audio and click it again. Otherwise, this session is being recorded, and please take a minute to read and familiarize yourself with the Notewell. These are the terms by which we participate in the IETF, and as it is the first session of the week, it's possible that you haven't thought about this in a couple of months. So give it another scan, nod to yourself, go look it up online. Otherwise, enjoy reading it all over again. One other thing to note is we do participate under a code of conduct here. Thank you all for making this a very happy and friendly working group to be a part of, and let's keep that going. These are some helpful links that you can click on later. And we have an agenda today. We're going to start with some housekeeping. We've got Carl with Gory as a backup as a note taker. Thank you both very much. Then we have a couple of talks about some of our primary extensions that we've recently rechartered to explicitly include. And then we've got some additional individual drafts to talk about. Would anybody like to bash the agenda? Wonderful. Before we get too far into our agenda, we do have one other fun note, which is that our fine friends over at Occupop have designed for us our very own mask logo. It's came out very nicely. Has a little bit of reminiscent of Quick and some of the racing stripes, but otherwise is a very nice little masky shape up there. We've got somebody in the queue. Would somebody like to make a comment about our mask logo? Is it a badge? That's true. It is a protocol badge. That's a good point.
Do you have stickers?
We do have stickers, yes. Jumping several slides ahead. But yeah, so it's mask. We have some mask words that go with it. They go next to it. We can get different forms of it. And yes, indeed, we have stickers. There's a couple left at registration. We stole most of them and brought them in here because it seemed like this was the most applicable room for them to sit in. But yes, so we have both the mask sideways stickers and we have the mask little badge sticker with the curved corners. That's all very pretty. So yeah, come and grab some of our very limited stock up here at the end of the session.
We will order more. I expect them to run out, so the next IETF will have some more, just in case you don't get them today. Just don't worry.
We're going to have so much fun with our badge. And with that, the first thing on our agenda is quickware proxying using HTTP, which I believe means, Tommy, you are up. Do you want to share some slides from your phone, or do you want me to share them and pass you control? That looks like a yes.
Trying out the new MeetEcho client, so we'll see if that actually works. Hey. All right. Good morning, everyone. So today we're going to talk about our proposed extension for quick aware proxying through MASQ. We've talked about this a number of times before. The draft has not substantively changed since the last time we talked about it, but for context, the last time we talked about it, we did not yet have a new charter for MASQ that would kind of allow doing these extensions. And so what I want to do today is just do a quick recap of what this extension is, why we're doing it, have a discussion quickly about adding encryption to when we're doing forwarding mode, which I think is the biggest open thing that needs to be done. And last time we talked about wanting to have some sort of design team in the group to really dig into this, and I think that's still a good idea. And so I just want to update people on the current state of thinking, but as a hint, we're going to want to have a design group and design team to work on that. We'll cover some of the other open issues and then talk about what we do with this draft. Okay, so as a very fast recap, here we have the case where we have a client talking to the mask proxy. And instead of just doing purely vanilla UDP proxying, it tells the proxy other information about the inner quick connections that are being proxied. Specifically, it's telling information about the connection IDs as well as other properties that may go with the connection IDs, such as stateless reset information. And this allows the proxy and the client to collectively do a couple different optimizations. One, it allows the proxy to reuse the ports or the sockets that is using upstream to the next hop, because it is going to be able to demultiplex based on the quick connection IDs. And it also allows something that we call a forwarding mode, where the client and the proxy can, instead of re-encapsulating all of the end-to-end quick packets within quick datagrams going over, or H3 datagrams going over quick datagrams, it can just put them kind of directly on the outside, because it's able to demultiplex traffic that is bound for the end target with traffic that is bound for the proxy. And in the original incarnation of this, we just sent the end-to-end traffic just on the same ports, but didn't modify it at all. The current draft talks about swapping the outer connection IDs for virtual connection IDs to make sure that they're not the same. And then the discussion we're going to have later about kind of re-encrypting the whole packets means that the packets on both sides of the forwarding context will look completely different, even though it's a very, very simple transformation that needs to be done. And you could, hopefully do this all within BPF or some very low level forwarding layer, rather than having to re-encapsulate all the way up into the upper level of quick and re-encrypt, etc. Okay. So there are a couple different capsules that this protocol defines, and it's a good way to exercise capsules in general. The client can register a connection ID that it has as its local connection ID for a flow that is proxying through. The proxy can say, yes, I have kind of registered that one successfully. The client can register target CIDs as it learns about the destination CIDs from the server that it's talking to at the end. And they can negotiate these. And this is also how they set up the virtual connection IDs or stateless reset tokens that they're going to use on their link between the client and the proxy for this end-to-end forwarded connection. All right, so the main open issue is how we want to add encryption around this forwarding context. So again, the current draft talks about just swapping the CIDs, but not the entire payloads. So if you have an attacker, a passive attacker that's watching traffic on both sides of the proxy, they are able to recognize, oh, this is the same packet that was on both sides of this. Now, that's not necessarily a huge problem in all cases. They're just kind of learning what the next hop is. But ideally, we aren't going to give away any more information than we want to anyone passively observing this. And I think we all agree that there are definitely better privacy and security properties if it's not trivial to correlate these. Now, of course, you could have timing correlation or packet size correlation, but those are things that could hopefully be fixed other ways. So I think the direction that we came out from our last meeting was that, yeah, let's just encrypt all the bytes. It prevents the trivial correlation. I think there was some discussion on the list recently that I think Ben had brought up about the difference between a passive attacker and an active attacker in this case. Um, I believe the discussion we're having here is just about preventing the passive attacker from trivially correlating the packets on either side. Um, if anyone disagrees with that or thinks we should include more in the scope, please let us know. And then based on our list discussion, where we were coming up with the different possible directions we could take here, it seems like an AES-CTR approach for doing that re-encryption seems to be workable. And I think a lot of it just comes down to how do we actually want to instantiate this? What are the IVs we're selecting? Are we able to do this as a single pass? Do we have to do it as a double pass? And this is the type of thing that we would want to ideally discuss with a design team. Christian.
Yeah, I should have raised the issue on the list, but I don't feel comfortable with having this special treatment of bypassing quick and making packets, etc. And I very much like the idea of having optimization for the quick and quick. I wish this behavior of forwarding packet in a special way could be negotiated separately from doing quick and quick. I wish that we had a baseline in which we are doing quick and quick mostly to save on the number of maybe bytes and relayed or something like that, but that we would just forward it as a straight datagram, and that we did not do this premature optimization about trying to not completely redo encryption.
Can you clarify the parts that you wanted to separate here? Again,
anything that is related to not doing, I mean, basically, I would like the baseline to be the same as forwarding a UDP packet, with optimizations such as we can use a single port and things like that. I think that the valuable part for me is to have a limited number of UDP ports open in the relay, because that makes deployment much easier. But I like the part of quick aware that reduces the usage of the number of open UDP port in the relay.
Got it.
But
yes.
I would rather do without any kind of special treatment and special encryption for the relayed quick packets.
Yes. So the way it currently stands is that the support for being able to do forwarding is negotiated, and both client and proxy need to consent and negotiate to do that. And so it is certainly possible, with how the protocol is defined here, to simply just share the connection IDs and be able to do the port sharing and do nothing else. So that is entirely supported.
Okay.
We do know, like experientially, for cases where we are doing multiple proxy chains, or chains of multiple proxies in a row, that not having to do the re-encapsulation is definitely beneficial for both reducing the encapsulation overhead and loss of MTU, as well as the CPU usage and like required hardware deployment for the proxies themselves. So certainly not everyone would need it, but it definitely does have benefits in the deployment we have.
Well,
All right.
Hi, Eric Sprolet.
Hello.
So I share some of Christian's discomfort. When we did a bunch of like freelancing and designed the quick packet protection mechanism, we did it by demonstrating to ourselves that it could not possibly that we hoped it could not possibly compromise the plain text. It could only compromise potentially the sequence number. This does not have that property. This is like a primary security mechanism, which we are proposing to design like largely. Yes, David, I know you're going to say like it's not the end-to-end data, but it's like the whole point of the proxy is to protect this information. So like, I find it quite hard to reason about like what this does not do. While I do share the concern about the MTU and the CPU, I think that like to say, oh, we're scoping to passive attackers is like substantially premature without some real analysis. And this ASCTR thing like may or may not be okay, but like this like needs real work and it's not like something which can be like banged down the weekend. So I think like I don't think we should make this first point decision you're making earlier, and I think that
which decision?
That we are scoping to passive attackers, and I think that the acceptance of this entire mechanism at all should be subject to real security analysis, not really best effort. What I mean to that is forwarding mode should not go forward unless you can demonstrate acceptable set of security properties, and by demonstrate I mean not be hand waved.
Not be what? What was the last
not
part?
be hand waved. So,
sure. Yeah.
Well, I guess, but you're drawing the analogy. You're drawing the analogy to the packet protection mode, to the packet number mode, which was in fact hand waved. I had a part in it, and so I don't think it's acceptable for this situation. So the point I'm making is that like if we can't demonstrate that, then this should be removed. Not we just do the best we can.
Yeah, I mean, I do. So I would like to have a more in-depth design team kind of go over the different properties here, and the base idea for the ASCTR stuff is what MT was proposing. So I think we should dig into that more.
Right.
I mean, overall, I do think that even as it stands with forwarding mode without re-encrypting, that is essentially using the proxy here not as kind of an extra security mechanism, but as a NAT that you have a handshake with.
Sure.
And like that, at that point, your security properties are roughly the same as what you would have if you didn't go through the proxy from a lot of different attack mechanisms. But
I don't necessarily disagree with that.
right.
But the question is, what should be in a proposed standard?
Right, and like I think there is still value for certain deployments to be able to have that type of scenario where I'm not necessarily trusting this proxy to add a lot of security beyond what my other hops are doing, but I still want to be able to do essentially a path selection and routing through this proxy.
I do understand the point you're making.
Yeah,
and I'm disagreeing with you. So again, to restate, my view, which others may or may not share, is that this mode should not exist unless we can demonstrate security analysis that it provides real security to that hop.
And so can you describe
sure.
So if we have beyond the passive attacker, what are the active attackers? What are the other security properties that we want to protect against?
I think that the benchmark, the reference benchmark is doing what Christian said, which is simply double encapsulation. And so,
sure.
I think you need to quantify precisely what the security loss is between those two.
Okay, so the difference between, so what are you losing by not re-encapsulating? Okay,
and I guess I haven't worked through what the encapsulation loss is, but are we really saying we can't afford 10 octets? Like, are we saying we can afford 50? Because they're different, and there certainly are things you could do which would be better than this, but perhaps worse than full encapsulation. That would do more than resist passive attackers, right?
Yep, that's fair. I'm happy with that.
Watson Lad, Akamai. I think there's some history with these kinds of lightweight packet protection, not trying to change the length from the Tor project. And what they found with AES counter is that you open the door to tagging attacks, where the attacker makes a bit flip, can see, and in Quick, because Quick ignores packets that fail air protection, the attacker can see which of the flipped or unflipped one at a later proxy in the chain works. And that means that we have a chain of proxies who don't necessarily get the connection properties you might want. So
Because the individual proxy is not validating that there wasn't a bit flip along
the
with
individual proxy can't.
Right. Yes. Yes. Right.
And so they ended up trying stuff like lioness and tight, and there's a whole history here,
Mhm.
which I think if you, depending on the security properties you might want, and I think with a sufficient encapsulation, it's sort of tempting to say, okay, well, why have all the, why not use this for Tor? And the answer is because there's a lot of security issues with doing that, which I think we should look at and decide.
Mhm.
Hey, should we learn from this if that's our security model we're going to go with?
It's good. Christian?
Yes, I mean, Iker made a lot of the points that I was wanting to make, and in a more clear way. An additional point is that I think we have to be very careful to have the proxy not make hypotheses that go beyond the quick invariance. And it's tempting when we do optimization to basically make hypotheses about, hey, quick v1 does this, etc. And we see things happening like multipass, which changes the way the packets are encrypted. I really, I don't feel comfortable with doing optimizations now. I understand that we want to save CPU and MTU, but there is a history of doing premature optimization that go bite us just later, and sooner rather than later, in fact.
I mean, understood. I mean, to the point of premature optimization, like again, in practical deployments, this we have measured it doesn't make a large difference on the ability to actually scale this up. So it was a necessary optimization to do in order to get some practical deployments at scale for us.
I don't know, because I mean, if you chain relay, it's probably because you do some kind of onion routing. And like, if you're trying to chain relay and replicate Tor, for example, having those optimization may have very well unintended consequences.
Mia Kulevin, I want to disagree with Eka a little bit because I think having the full encapsulation as a baseline doesn't make sense. If you want the secured property of a full encapsulation, just do it. Don't use this optimization. But this is still gives you some features you may want compared to just an end-to-end connection, right? So I think like seeing this as an optimization which should have the same security properties doesn't make sense. Like if you want the security, then encapsulate. But we should be more clear about this in the draft that this is just not replacement, it's a different use case.
Yeah, David Skenazy, mask enthusiast. I want to agree with Virya here. I think if you look at what Apple has deployed in production to, what is it, hundreds of millions of users, they have something that works that is this without the encryption. And that's what allowed them to ship their iCloud Private Relay feature as opposed to, let's say, a two-hop mask. Because in their case, they have their own data saying that it didn't work out for them. In other cases, let's say you want to use mask for Tor, which sounds really cool. You don't want this because the attacks that Watson was talking about are a problem in the Tor use case, but not necessarily in the private relay use case. So the question kind of where we go there is, do we want to say, well, no, this is not as good as regular Connect UDP, so you should use a NAT instead, and that's, IETF is standard, and we won't let you do this? Or do we say, well, do we want some kind of middle ground that's nowhere near as good as regular Connect UDP for security, but maybe good enough for a use case like Apple's Private Relay? Or, Google's looking at building something similar, and we haven't deployed to production yet. We haven't measured. Right now, we're starting with regular Connect UDP. We're following this draft very closely because we might run into the same problems. We might need this. We don't know for sure, but I think there might be a role for this in the wider ecosystem of what mask can do.
Now, I mean, just comment on that. Like, certainly, I would like to add the re-encryption and kind of make it have more of the properties that Tor can have. And the point that Watson brought up about the problems with just doing the ASCTR, like that's good. I think we should analyze that and understand what the trade-off is and the loss is when we do that. Sure.
So, I mean, since I've been name checked twice, I think I'd like to clarify what the position I'm taking is, which is that the baseline for analysis ought to be the full encapsulation. And the job of the analysis is to quantify the gap between the full encapsulation and this thing. And until we can adequately do so, we should not proceed. And then once we've done so, then we can assess whether that gap is acceptable.
Yeah, that makes sense.
Martin Duke, Google, not only not wearing hats, but actually speaking on behalf of Ryan Hamilton from Google.
Wearing someone else's hat.
Yeah, so he is, and like I think it's a legitimate concern, obviously. Like by removing the double encapsulation, like if you don't have encryption, then there's no authentication of the packet, and it seems like there's some threat models where the people could inject random garbage with the virtual connection ID and get the proxy to do things. So I think that's probably an important thing to include in the analysis that Ecker is suggesting. Thanks.
Yeah, that's a good point. I do believe, like, if you got a connection ID, you wouldn't recognize to handle it by, either you drop it, etc. Also, like in the cases we're thinking about here, like this is always for like intermediate steps of the proxying, not like the end servers. And so like the next proxy would catch it too.
So to be clear, so I think the threat model is there's a passive attacker like hanging out on the client to proxy path.
Yeah.
And I observe virtual connection IDs.
Yes.
And I just send packets, garbage packets with those virtual connection IDs. Then I'm spamming the target with stuff that the proxy will admit.
Right. That's right.
Because there's no admission control as there is with a mass connection. Yeah. Okay. Thank you.
Yeah. Yeah. Which is why I do think like it makes the difference of like, is the next hop just yet another proxy in the system versus like the end server that you're allowing to get garbage. Yep. That's good. All right. I think the next slide was just a brief overview of where things were currently for the ASCTR proposal. I don't know, David, if you wanted to comment to this at all, just to explain where the current thinking was.
Yes. So just really quickly, multiple people, like I think initially Martin Thompson came up with one potential design. I had one. Then I think this one is from Ben Schwartz. Long story short, because you're working on like your plain text here is an encrypted packet, your kind of properties are very different. It's like random data as opposed to your usual plain text. So you can do some things that are kind of simpler than the quick header protection. So like the proposal here is UAS CCP one block of the first 16 bytes and then use that as a nonce to key an AES CTR key stream for the rest of it. Clearly, this isn't fully fleshed out. Many details need to be figured out, like which keys do you use for these things? How do you grab them? Are they per connection ID or per connection? And this is the kind of thing that's really easy to get wrong. So I think, to Ecker's point, spending some time on the security analysis and the threat model of like, what are we actually trying to solve makes sense. But then once we get a clear picture of that, I would really much be a proponent of forming a design team, because speaking as one of the editors, I think we could use a lot of help to get this right.
Yep. Agreed. All right. So the only other content I had here was talking about some of the other open issues we had that various folks have brought up. Eric, did you want to just quickly talk through some of these? You can come up.
Yeah, so outside the encryption one, there's a few open issues that we thought might be worth bringing up. Sorry, can you hear me? Thank you. Break it off. So this first issue is quick version compatibility. So the gist of it is our capsules for registering connection IDs include things like connection IDs that are allowed to be up to 255 bytes, which aligns with the quick invariance, but it also includes things like stateless resets, which are not part of the quick invariance. So how do we want to kind of square these things? We want to align with quick invariance so that we can proxy all versions of quick, but at the same time, we want to be able to handle some version-specific properties of quick. So are there any thoughts on this one?
Martin Duke, Google again. Yeah, thanks. As like a guy who's overthought the version thing, thanks for trying to consider this. Yeah, I mean, like, so in the Quick OB draft over in the Quick Working Group, we have a section on version invariance of the design, which I think a similar thing would be appropriate here, which is like, what assumptions are we making in excess of RFC 8999? Because I think like while that's a fairly small set of invariants, like I think there are a lot of assumptions that in practice are probably pretty safe to make about future versions of Quick. And it just like documenting where you really have to deviate, you know, go beyond 8999 is good. Like if stateless reset format changes, is that something where you could like configure the proxy to just stop doing that? Or like if it is sending these stateless, if it is assuming that it's 9,000 and you're sending stateless resets, like what happens? Does it break something, etc.? So I think a section like that would be appropriate, and I think it's actually pretty straightforward to write.
Yeah, thank you. At least in this stateless reset case, it's an optional field, so it could always be not provided. But yeah, that's good feedback. Thank you.
Yeah, I mean, like I guess it's feasible for a proxy to like look at the version and like figure out what it can do, and or if it should like you could actually change the design if you wanted to and have like a version aware mode and like a not version aware mode that like had a stripped down set of capabilities. I mean, that's a possibility. I haven't done any analysis of it. But again, thanks for working through the space.
Thanks.
Mike Bishop, Akamai. I will echo that having it be optional, and also if we are going to have version specific capabilities, having a way to plug in appropriate capabilities for future versions we don't have yet. So I think maybe not just having it be an optional field, but having an identifier of this is a version 1 stateless reset because I'm planning to use that. And I might be able to tell you about a version 67 something else another time.
Awesome, thank you. All right, so the next one here, the tunneled mode is subject to 2 congestion control loops, one between the client and the proxy, and the other between the client and the target. But in forwarded mode, we lose the congestion control loop between the client and the proxy. And so this kind of starts to beg the question of, in certain deployments, does forwarding mode actually give you some performance improvement? Or by foregoing that congestion control loop, are you actually hurting performance? So this probably deserves some kind of consideration in the draft. It seems most relevant when the proxy target RTT is the highest. But yeah, are there any more thoughts on this one? I think we're also short on time. All right, and then this last one is connection ID compression, which I think was in the original MASQUE draft. And so what if you want to do forwarding mode? Or sorry, what if you don't want to do forwarding mode, but you still want to reduce the encapsulation overhead? You don't want to have to send the full connection ID on every single packet. So this becomes increasingly relevant if connection IDs get really large, because the cumulative MTU overhead of encapsulating over and over again becomes more significant. But then if this is something that we want to do, should this be a separate extension? Should this be part of this draft? Open to your thoughts.
Hi, Eric Squirrel. Yeah, this is going to come up again in the next talk, because the overhead of the packaging for the if you want to use something like Mask for something like WebRTC, and you'll have media, then the overhead of the encapsulation becomes quite large because the packets can be quite small, especially if you're doing voice. So I think this is something that needs to be looked at, and I think that like it should not be here. It should be, sorry, in this working group, but not in this draft.
Yeah, I'm not sure I agree with that, but I think the answer to this question will depend on how much the forwarding mode manages to get us, right? And what the security properties of that ultimately will be. So I don't think we can decide here.
Yeah, Kulin, I just wanted to ask, why should it be in the same draft? Is there, I mean, it feels like really two separate things to me, or is there anything that actually is the same and therefore makes sense to describe them together?
I don't know if anyone, or Tommy.
It was just one of the issues raised on this of like, oh, you're quickware. My personal opinion is that we should and can define it separately.
Yeah.
And that would make it orthogonal, and maybe you could use it together, maybe not. I mean, it is a good point that MT brings up about, you know, it matters more or less depending on if you're doing forwarding mode or not. So anyway, I think this is the last of the issues. So last time we had seemed pretty favorable about this. I think this time there were more concerns brought up. I do think in general, it seems like we need to do more, you know, serious design on what the re-encryption would look like and what the security properties are and the analysis there, more than just like a couple emails on the list every now and then, if we want to consider this. So I don't know what the chairs think about process-wise for like design teams for something that we haven't formally adopted yet, but it seems like it's something that we want dedicated effort on in order to make progress here or not. So I would ask that we do spin up something, since I believe, you know, this topic area is within Charter now, so we could just have a design team to get into the nitty gritty and do that security analysis.
Yeah, so this is not a working group document yet. It might become one eventually, but I don't think anything stops you from just forming, you know, a group of your friends to work on this before it becomes a working group document and call it a design team.
Sure, but
I guess
I
from
mean,
my perspective,
it'd be nice to have, like, I guess I'd ask to like have like a working group, like driven design team that.
I think we'll reserve that for working group documents.
Okay.
Right. David, did you have a comment?
David Skenazy, process enthusiast. I mean, we can rat hole for a really long time about whether or not you can have a design team on a non-adopted document, or we could talk about adoption.
Right, thank you. All right, so based on the conversations here at the mic, it seems like one of the things that is not super clear is what the potential use case for this is in practice and what the value of it is. So in order to sort of get towards an adoption call, we're going to do 2 show of hands. First of which is just to tease out in the room whether or not the target use case for this particular draft is clear. So I'm going to start that now. Simple yes or no question: is the target use case for this document clear?
There are 2 use cases, but
sorry.
I'm just like, there are multiple use cases here, too.
So. Okay, so plural.
Do you see a use case?
Okay. I'm going to end it. So it seems fairly clear that at least one of the use cases that's in the document is clear to people, which is great. And then given that now this is explicitly listed as an item in our charter, I'm going to do a second show of hands to ask if there's interest in adopting this draft as a starting point to address one of these use cases that is clearly articulated in the draft. Yeah, Corey, did you have a question? The 20-something to 7.
26 to 7.
I want to note that, yeah, I want to note that as discussed at the mic and as I commented in the chat, we will not publish this absent security analysis that guarantees that this is safe to do so. We understand what the implications of using this particular optimization are. And that seems like perfectly reasonable work to do in the working group.
The working group could remove the forwarding mode too if it decides.
For example, yeah. Eric, go ahead.
Yeah, I think I don't object to adopt this document. I think that's the right thing to do, to work on it in the working group rather than have it base over rump thing.
Great.
But I think that the process here should be that there should be a formal consensus call to retain this once the security analysis is done.
Yes.
As opposed to being the burden should be that it has to be agreement to do it rather than someone has to fight it out, take it off.
I would argue that kind of whatever the outcome of the design team or whatever on this, there should be a consensus call to adopt that, no matter what it is, to keep or remove.
All right. So I'm going to end it now 39-1, Corey, if we can note that. So seems like there's strong interest in adopting this. We'll confirm on the list.
Thank you.
And then we'll talk about design team process.
Great.
Stuff
Thank you.
Thank you, folks. I think next up we have David or Abhi. Great, Abhi. Do you know how to drive? Sure, we can, but you're able to do so there, but we can do it.
Okay, here, I see it.
Great. All right, take it away.
All right. Hello, everyone. I'm Abhi Singh, Google. And we're going to be talking about the MASQUE ConnectUDB listener. So I've actually presented the same thing over the last couple of IETFs, but recently we had the recharter and an opportunity to perhaps adopt this. So ConnectUDB as it stands. So it allows only single 5 tuples, which means you have a ConnectUDB connection with the proxy, and your UDP payloads are forwarded from the proxy to the target, and the target is specified through the well-known path in the header. So we do have limitations to what we have right now with ConnectUDB, which is if we want to connect to multiple targets, we create a connection for each from client to the proxy. So it is possible and probable that the targets, like different targets, will see different source IP addresses for the client, because there's no guarantee that the same instance of the web server would forward the packets. So it could be different IP addresses and different ports. So I'll give you a use case. So let's say Bob and Alice, they want to talk to each other. And let's say Alice is behind one of the proxies and Bob is behind a NAT. And the NAT is address port dependent. And you'll see that like ConnectUDB, the way we have it right now, it kind of acts in a similar way to an address port dependent NAT. So yeah, so they talk to a server in the middle, and the server learns both of their IP addresses and ports. And then the server tells each of them like where the other is. So Alice learns Bob is at address B, port B. Alice learns like Bob learns it's at AA, and Alice learns it's at BB. However, if Alice tries to connect to Bob, the NAT will reject the connection further because it's an address-dependent mapping. So the NAT doesn't have an entry for Alice to connect to that same to connect to Bob. And also Alice, what you'll notice is Alice is sending from a different IPN port as we discussed before. So even if Bob was informed about the IP address of Alice, Bob has AA, not A dash A dash. So this connection would get rejected. Likewise, if Bob tries to do the same thing, it will get rejected because the proxy kind of acts in a similar way. So both of them, they kind of learned not super useful information about each other. And in WebRTC, unfortunately, the only option would be to use a server in the middle, to use a turn server. And so in the world of stun turns and turn and nats, as long as at least one of the clients is behind a less restrictive NAT, WebRTC connections can be directly established. Peer-to-peer can be established without needing a turn server in the middle. So if both are behind address-dependent NATs, a relay just needs to be used. And like with Connect2DB, the way we have it right now, it kind of resembles that. So, which is kind of problematic because we already have two proxies running. Why do we need a third one in the middle? So our proposal, Connect2DB with listener support. So use the same connection and target multiple targets. So we're kind of resembling a better kind of NAT. And I want to give credit to Eric Rizcola. His blog was super informative on this, and it really, really helped us kind of understand even our own problem. So we're kind of resembling endpoint independent mapping. So for the same client, the server is kind of using the same IPN ports to connect to multiple things. And so as long as either one of the two is behind like less restrictive properties, like here, we should be able to connect. And you'll see this is one of the examples of these kind of with two NATs that have like address independent mapping, but address and port filtering that connect to each other. And they're able to connect because eventually one of them is able to create a hole. Like the first packet gets filtered, but the second one won't, and it works. So yeah, I just explained this one. Okay, so how does it work, what we're proposing? In the path, we put two asterisks to indicate any destination. And of course, so we'll also add a context ID for Connect2DB listen to specify this is Connect2DB listener specific. And in the datagram, as you can see, each datagram has an IP version, IP address, and UDP port to target where the packet is supposed to go. And yeah, so if this was being sent from the client to the proxy, this IP address and port would determine the target port where the packet should be forwarded. And when being received back to the client, this indicates the source where it's receiving from, since we have multiple connections. And so that's pretty much it. That's like the gist of it. And I'll go over some open issues real quick. So the first one we had is allow the proxy to send the public IPN port to client. Do we want the client to be able to query its own IPN port? Normally, like in WebRTC, it's going to use a stun server to find its own reflexive IP and stuff. But if we already have like a connection to our proxy, we might as well be able to query it ourselves. Would that be useful? Yeah, go ahead. Sorry.
Yeah, Eric Scrolla. Yes, you're sort of like, I think I observed at the last meeting, you're sort of triumphantly reinventing every feature of turn. So really, someone should take a look at turn and map on the features that make sense rather than reinventing them first principles. Turn already does this. This is like when you do an allocation in turn, it tells you your server reflexive address, or actually your exterior address.
Right.
So yes, you should do this, but more generally, you should read turn, which really has solved this problem. I think when we get to the next, this should be in the response to the. So I mean, like, I would simply adopt the turn strategy here, which is that you do an allocation, which is the thing in the previous slide, and the response is the allocated address.
Right.
And that's how the answer should happen. I'm going to step back for Lorenzo here, but like, I'm going to up the mic several times to say the same basic thing, which is you can just steal every single piece of turn rather than trying to invent them.
That makes sense. Thanks.
Lorenzo Colidi, also, yes, we should do this. I think more in general, I'm trying to think about how can we coming at this from the perspective of IPv6, where we did like this is about like basically internet forklift to like try to support end-to-end connectivity again, right? I think we should think about how do we retain end-to-end connectivity through proxies, right? Because on one hand, it's like really important to have proxies to protect the user IP address, but we also want applications not have to deal with a bunch of complexity like this.
Right.
And one thing that I think, for example, on certain operating systems like Android, less so for iOS, is like, apps are basically like fundamentally dealing with very low-level sockets APIs, like, connect, get sock name, get peer name. I think one thing that would be great is to think about how can we implement those through a mask proxy. In this case, for example, one thing that these applications do is they basically call connect to a remote address, and then they call get sock name to figure out their local IP address, and then they transfer this over an out-of-bound channel, right? They basically say, hey, here's my IP address, and of course with IPv4 this doesn't work, right? But in IPv6 it does work today, and so we should make sure that this sort of UDP socket semantics works. And I think, I think ideally we would make it so that whenever you do connect UDP, it just behaves like a UDP socket. It has a local IP address and port, which is actually living on the outermost proxy, and that stays constant. And ideally, when you talk to the same endpoint, you have the same one, right? Because if you then open two sockets, right, like it would be really nice if you had the same IP address and for the other host to know that it's you, right? So
of course,
basically trying to think about, okay, like how can we like emulate end-to-end a little bit better? And this is, you have to do this for sure if you want to do that.
David Skenazy, Mask Enthusiast. First to answer Ecker's point, this is definitely reinventing parts of Turn. But in case y'all haven't noticed, we've been reinventing socks, and then we've reinvented IPsec, and we're running the internet over HTTP now, but don't tell anyone. So conceptually, you can do this with Turn, but I think Abi did a good job of explaining that if you have regular connect UDP, you end up needing a turn server, and that means that now you have another point on failure on the path that every single data packet is going through. So this, sure, from the protocol perspective, it seems like reinventing the wheel, but from a deployment perspective, it means that things will work better. So, sometimes some work duplication is a good thing. And then to Lorenzo's point, I agree. Like if you look at Connect UDP, conceptually what it is it gives you a connected UDP socket where you can send and receive, and it always goes from the same local port to the same destination. And this gives you a unconnected UDP socket, which is why we ended up calling the draft Connect UDP listener, because you can call listen and all those things. And this is an example of a feature that would enable some of those calls like get sock name to actually work.
Tommy? Okay. Lorenzo.
I guess to be a little bit more concrete, like basically what David said. I think to be a little bit more concrete, for example, when you call connect on a UDP socket, the POSIX semantics are this, that your port will not change after you do that. And like this, the local port doesn't change, right? And you could call disconnect, and then that will get reset, right? But maintaining those semantics would be really helpful to like not break existing apps, like so that you can basically like forklift apps and run them on this. Because again, think about an OS where like everything uses sockets APIs. If you just like emulate them correctly, then all of the apps will work. If not, you're sort of in a world of pain. So,
I mean, regular ConnectUDP just connects to a single client, and for that case, it does stay consistent, right? So,
but you can't get the port number, right?
Right. Yeah.
So yeah, so that should just go away, right? We should just do something like this. But I mean, unless you're like just doing a flow thing where you really don't care, right? But yeah, the other thing is like when you call send to on an unconnected socket, you basically commit. I think it commits a port number for you, and that won't change on that socket, right? So we need to like kind of like emulate that as well.
Makes sense.
Yeah, Eric Scroll. So David and I were chatting offline, and it appears that maybe it wasn't clear. I think this is fine to do, but I think that the way it should be done is by copy and pasting turn into this, rather than by iterating through and finding problems and fixing them. So that's my thesis. Not that we shouldn't do this. I agree. Turn is like as I think I made clear when I read about turn, it kind of feels pretty clunky and old, and it's like worth reconsidering. And in fact, that's going to be relevant in about one slide.
Yeah, I think it makes sense. So, speaking of copying turn, restricting IP addresses. Again, this is something it's already done, which is like, so we wanted to ask the working group, oh, do we want to allow all IPs through, or do we want to have an allow list? But I believe turn already does it through allow lists.
Yeah, so I think let me try to like flesh out for people what the context of this is, which is when Turn was designed, there was a pretty standard firewall configuration policy is outgoing connections only, right? It's phrased with TCP, with UDP, it's done with like stateful inspection and with timeouts and stuff like that, right? And that's why NATs behave the way they do, for instance, right? And so when Turn was first designed, there was an enormous amount of concern that if Turn had an incoming connection facility, that it would be then used to bypass firewall rules, and the consequence would be that enterprise administrators would block Turn. And so Turn was specifically designed not to allow incoming connections because they were concerned about the knock-on effect of that. And so now that was 12 years ago or whatever, so things may have changed. But the reason for that design decision is that. And so if the IETF wants to make a different decision and say, actually, we think firewall incoming, no incoming rules are stupid, that's like totally reasonable for IETF to do. I'm not sure what I think of that myself, but that's why Turn's designed the way it was. And so I'm not aware of any other real reason why you should be limiting incoming connections under the circumstances. It's not like you don't accidentally make like an incoming UDP server like out of your thing. Well, it's not quite true. There are like sort of rate limiting kind of concerns we can talk about in the next slide. But that's why turns the way it is. So I think like we should make a conscious decision to not do that if we're not going to do it. I don't actually know what I think about it.
Right. David?
David Skenazy, firewall enthusiast or not. So to add to what Ecker said, yeah, Turn, one of its properties was that it was distinguishable on the wire, which in a lot of cases was a feature, not a bug. But there was really a fear at the time that firewall operators would block it entirely because they would see it as a threat. Let's just say that we haven't really been operating with that mindset in Mask. So here we don't have this problem because this whole thing is designed to look like regular web traffic if you don't have the encryption keys. This whole thing being an HTTPS connection. Yeah, traffic analysis, I know. Yeah. So you can look at what the IP address is, but you can't look at a packet and go, oh, clearly this is mask inside the HTTPS connection because it's encrypted. And so this was a feature of Turn that sensory specific for Turn, and I think we should ask. I personally don't think we need this, and it's something that we could add later as an extension on top. But it's worth, like Ecker said, having that conversation, but post any adoption conversation potential.
Alex.
Hi, Alex Chernowski, Google. I just wanted to say that there is another very popular protocol that lets you do incoming connections. It's called SSH.
and it is generally widely accepted, even in most corporate environments. So like, I don't think that this particular turn feature is one that we need to be worried about.
You can. So I think, I mean, there is sort of one more reason, which, as I say, may not be a particularly compelling reason, which is, essentially the consequence of opening up an arbitrary UDP port to any location is that you get a lot of packets. And so one of the nice things about having basically address-dependent filtering is that once you basically, again, turn emulates basically NAT bindings, and so it times out. And so once you basically used ICE to establish the host port quartet you want to talk on, then basically turn closes off the incoming ports after 5 minutes or whatever. And so the consequence is that packages bounce off the relay rather than get made to you. That's like not a huge issue, but it's another reason why we want to do this. I certainly I don't think any of this precludes adoption. I think we certainly just make all these decisions later. I'm trying to give some context for why things were designed the way they were, and whether those things continue to hold.
A couple of observations on that. I guess one thing is, automatic timeouts are sort of good to emulate NATs, but they're really painful to deal with if you're an app, right? So, and they're really expensive to, sending packets every now and then is like really expensive on sort of 3GPP networks. So it'd be nice to get away from that. Like with IPv4, you kind of don't have a choice, but I mean, a lot of carriers today have, sub-minute timeouts for UDP NAT entries, and that's just excruciatingly expensive. The other thing for the allowless to remote IPs is like, while yes, it's okay to say a network administrator, oh yeah, this is fine, don't worry, the app will only allow incoming connections from the remote endpoint, it does boil down to like, trust the app.
Right.
And so this may not be a very sort of appealing guarantee to network admin. Yes, I understand now, like, turn was done for this reason, but if that's introspectable over the wire, then that's a completely different thing, because you can tell a network admin, oh yeah, go buy the security gear, they'll do a bunch of DPI and ensure that the app is only receiving connections from the endpoint, whereas this is like completely opaque, as David said, right? So I don't know how, this is basically, trust the app, like the app can tell the proxy that it's only going to receive from this particular endpoint, but you have no idea to know if it did. So I don't know how helpful it's going to be.
Wu from Meta. My question is not about product, it's about the implementation. So in your diagram, we have one instance of proxy. Do we consider this proxy is fronted by like a layer 4 load balancer? So which is mean we have multiple proxy instance. When we create a listening socket, does it mean we should create a listening socket on all proxy instance or not? So I just wanted to understand this because turn have this issue. So when turn design, we don't consider this like a layer 4 load balancer, so which create a lot of operation issues. So if we want to solve this problem or solve similar problem, turn try to solve, let's consider the layer 4 load balancer before proxy.
Go ahead.
Jumping in as co-author to answer that. So in our implementation of Connect UDP, what we ended up doing was that we have ingress IP addresses and egress IP addresses, so that the incoming HTTPS connections to your mask proxy go through an L4 load balancer. And so, if it's H2, it'll do the 5-tuple magic. If it's H3, it'll go and do connection ID magic. But then all of the outbound traffic, so let's say if the user sent a connect request and we're creating a TCP socket, or connect UDP and we're doing UDP, those are on a separate address range that is, well, magically not through a load balancer, in practice through another load balancer that's configured differently to make sure that those things route back. So in practice, we need to solve this problem, but I don't think we need to solve it in this document, because this problem needs to be solved for Connect, for regular Connect and regular Connect UDP, just as much as for this.
Yeah, 3 points. First, I mean, denial doesn't get you deployments. So, I mean, what Iker said is correct. I mean, we have to consider the impact on deployment,
Right.
whether we like it or not. The second point is that there are really two scenarios. I would say basically there is the ICE scenario, which is the WebRTC scenario,
Mhm.
and there is the server from home scenario in which you somehow export your server at home to a proxy, and that's pretty much the load balancer scenario. I think that we might be better off treating the load balancer scenario separately. As in, if what you want to do is export a server, then maybe that's not mask, maybe that's something else. And the reason I say that is for the purpose of being able to distinguish between the two things, which will probably get us better deployment in the end. And my preference would be to solve the server scenario without making the H3 hypothesis, but we can do that any way we want. And the third point is that if we do consider the ICE scenario, then everything that Iker said is relevant, because in the ICE scenario, the client that's trying to connect pretty much knows the IP address of the peer. It doesn't know the port number that the peer is going to use, but it knows the IP address of the peer. So in that case, it's possible to basically do some kind of filter modification that says, I want to make ICE work now, which will accept things on IP address without bothering with port controls. And that's probably the kind of compromise that we have to study.
So to clarify, you're saying we should have, when we want to use ICE, we want to temporarily unrestricted? Not very clear on.
Yeah, it's well, you have two ways to unrestrict. You have one way to unrestrict. The basic restriction is completely symmetric. Is that basically you have to say it works for that four tuple, it doesn't work for anything else.
Mm-hmm.
You have another way to unrestrict is to say, okay, I am trying to establish an ICE connection with this particular three tuple, not four tuple. Saying, hey, I want that IP address, or maybe that set of IP address to work, which is different from the whole world. But it boils down to doing what Iker said, is basically look at what Turn did and do exactly that.
Right. Okay.
Yes.
Lawrence, could be a slightly different question. Do we have, is that so David just mentioned that the proxy that the proxy is kind of, if I understood correctly, the proxy is basically maintaining stable external IP addresses on a per client basis, or at least on a per connection basis. Is that right? Like when I do connect, that sort of
yes, on a per request basis.
Right.
Yeah.
So I think, but that's just what you chose to write. That just happens to be like what the code you chose to write.
Yes.
Now, I think we should try to think about, apps that are going to rely, apps that are sort of like need to go through this stuff. What can they rely on, right? I mean, I think I personally, I understand, I think I understand Christian's points, right? But I would personally strongly believe that we should not do something that's very restrictive. And I think we should say, well, we should actually like move the IP address to the proxy, but it should be sort of end-to-end connectivity capable IP address, unless the app wants its own protections, in which case it should opt into them. But I think, given that this is just like the code you happen to write, I think we should actually write that down and say sort of a mass proxy implementation should be in the business of providing these guarantees to its clients. If you do connect to UDP, don't change the local IP unless that connect to UDP thing times out or is torn down, right? I think so. I don't know. So as a sort of, presumably this is not written anywhere today.
Yeah.
I assume.
Yeah, of course.
So I guess the question would be like.
Sorry. So today, if you do two separate regular connect UDP requests, they might end up with different IPs. And that's a feature more than a bug, because from a privacy perspective, they could be different browser tabs. But if you do one connect UDP listener, it is guaranteed to have the same external IP and port because like the protocol doesn't allow you to encode it any other way. So it might not be explicitly written. It's an unwritten assumption that we should totally write down, but that's definitely for ConnectUDP listener.
Yeah.
It is that. I agree that in some cases, an app might get very confused if multiple sockets end up on different IP addresses, but that becomes a policy thing that we just say in, the kernel or wherever, those will come up on the same IP. But if another app does another ConnectUDP, it'll get a different one. That becomes a policy choice on how much privacy versus app compatibility issues we want to go. But there's a slider we can turn here.
Yeah, sorry. I'll just go through the last slide real quick, and then we can discuss a little bit. Yeah, so another thing from Turn is compressing, like as you saw, like we had the IP in every datagram. We could compress it and copy what Turn does for channels. So yeah, and that's what it looks like in Turn. Yeah, I think that's it. Eric, you can go ahead, then I'll.
Yeah, I mean, the bad news, right, is that even if you do that, you still have the quick packet overhead, which is substantial. Right. And so yeah, yes, you should. But it's still, I mean, so turn channels were done to save what? I think 36 octets. And if I remember correctly, with a quick short header and the integrity check, you're at like 20 right then and there. And then there's probably some framing garbage. So you're probably like 24 or something. Like even if this were like zero length. So yeah. So yes, you should, but it's still not amazing, unfortunately.
Yep.
So I think I don't know now. I mean, things may have changed in that, like audio, video conferencing is more common now than it used to be, and so obviously you can pair up the video packets with the audio packets. So certainly worth doing. But I just like want to say that, like, I'm not sure how great an audio conference on a low bandwidth network over Turn is going to over MASQUE is really going to be. But yes, you should definitely do this. Can you just go back
sure.
2 more slides to the point where you had this question about explicit, or 1 more maybe, but you had the explicit. You were saying you want to do I'll create a message, right? So just to be more history lesson, the reason Turn needs a separate message is because Turn send data indications and send indications are not integrity protected, and so they didn't want to accidentally create pinholes in the Turn relay firewall without authentication, and the control messages are. So you don't need to do that here. In this case, you could just have it as a side effect of X-line packet. So you don't need a separate message. And I think that partly addresses not completely the point Lorenzo was making earlier about the pain in the ass of keeping the pinhole alive if you decide to go that way. Because as a practical matter, if you're like on a video conference, so ICE requires you actually to send packets every so often anyway to keep the connection alive. So it's like a standard ICE stack will behave perfectly fine in this scenario with like 5-minute timeouts without any explicit connection reopening. So now, of course, things that are nice is different, but like the bottom line is, once you have absorbed this, like I got to go through NATs anyway, and I got to keep the connection alive, then it will work just fine if you just have it be a side effect.
So yeah, we'll just do the last one because I do want to do an adoption call after, like request adoption, I guess.
Yeah, I guess just one. Yeah, sorry. So I guess the one thing to think about is David's point was like, well, if you want to keep like an IP address, a constant IP address per, let's say, per app, right? So the apps don't get confused by this. That sort of has to mean that the client is somehow in control of the IP address that it wants, right?
Right.
And that's something that I assume that you'd need protocol changes to communicate that to the server. And so while I can see how you would say, oh yeah, like here, 2 different apps on my Android device should have 2 different source addresses because whatever, IPv6 source address is plentiful. That's great, but that means you need this other pipeline to communicate that. And communicating app identity does have, like, I suppose, privacy implications that we'd have to like carefully consider, right? So I guess one question would be, again, and I don't think it's great to have apps just find out in the field what any particular server does. I think it's important for app compatibility to have servers like at least play by some agreed upon set of rules, or at least the app can say, give me a stable IP address, or give me the same one that you gave me before, at least, right? So I think that's something where we should really think about. I don't know if it belongs in this draft. I feel that it might, because I don't want to slow everything down, of course, but like I feel that it might, because when you say like, give me a connection, give me a connection that can be used to receive stuff as well, I think it's important to say, okay, like here's how this is going to work for you. And I think it would be, and to be honest, I think it's great that we're thinking about doing this to support end-to-end connectivity. So hopefully we can get something that works well.
I think, yeah, I agree. I think it's worth discussing. So, so regarding adopting,
Are you all done?
Yeah, I think we're all done. Oh, is there some?
Kenji China Mobile.
Yeah.
Actually, I'm seeing some useful case for your draft here in the 3GPP for the extension on the ATSSS, talking about MP Quick. That is going to have a proxy. It's like a mask proxy running on UPF. That is like last hop router from the 5GS. So for the MP Quick, that from the UE and then to the UPF there, and going through the proxy HTTP on the UPF. So I'm thinking here, if you have your work from my side, well, from the 5GS side, this is useful, kind of like, say, from the UE to the UPF, you have MP Quick. I don't know, maybe 3 passes or what passes, and the proxy on the UPF and go beyond. So I can see some benefit from your work, but I don't know how make it perfect there. So just give you a sub scenario.
Okay.
Yeah, this is a good part. Thank you.
Hi, Alex Chernohovsky, Google. I wanted to answer some of Lorenzo's concerns by pointing out some of the observations that I have between Connect UDP and Connect IP and Connect UDP Listener. So if we go and take a look at some of the features that we've been discussing here, and one of the things that we intentionally did in the way that we have designed Connect UDP and Connect IP itself is that there's actually a substantial amount of overlap in this feature set and those two existing documents. So for example, in Connect IP, we do explicitly have a facility for please give me an IP address that I previously had, which allows you to have multiple streams or multiple connections even that can share an IP address. This particular feature that Abhi has been presenting to us today is a feature which overlaps very nicely between the existing feature set of Connect UDP and the existing feature set of Connect IP. You could accomplish exactly what Abhi's draft proposes today using the Connect IP machinery with the IP restrictions and the protocols and everything else that we have.
Yeah.
So like, and I'm not saying we should do this, but you could imagine this is a special case framing of a niche Connect IP spelling. And if we wanted to go and apply some of the lessons from Connect IP to this draft, we could basically go and exactly create the feature sets for, I want a stable IP address that you've given me before, let the apps manage that themselves, and have the identity and et cetera be sort of questions of non-issue, right? Because you also end up having the ability to apply some policy on the server side where it says, oh, no. I've already given out this IP address on this one existing connection from the same device. I'm not going to give it out to a different unique connection. And you could imagine having the pooling be happening there. So the way I would suggest people think about this is don't think of this as a Connect UDP extension. Think of this as an extension to the MASQUE family of protocols that currently has its primary feature set for UDP. How do we arrange the capsules that we have amongst the different variants of MASQUE protocol feature family in order to be useful more generally?
Thanks, Alex. All right. So other than yeah, the features we discussed, I think those are worth like discussing upon. But I think everyone agrees that there's a need for this.
Well, we'll let the working group adoption call assess that.
I don't see strong opposition to it.
All right. Yeah. So this is another item explicitly in the charter now. And given the comments and support that seems to be in the room here, I'm going to do a quick show of hands to see if there's interest in adopting this as a working group item. And of course, we'll confirm on the list. So the show of hands should be up now. Fill it out at your leisure. Okay, this is clearly going one direction. Goy, we can note 37-2 in favor of adopting it. 38-2 now. We'll confirm on the list. Thank you, Abhi. In the interest of time, let's move on to the rest of the presentations.
Thank you.
Oh yeah, tell me. Configuring proxies with PVDs. It's actually quite nice.
How much time do we have?
15 minutes.
All right. Hi, everyone. So this is a document that I actually submitted to under int area. I'll be talking about it in the int area working group meeting later this week as well. But it is very much related to MASQUE, and the motivating use case that we've had for it is discovering MASQUE proxies as well as discovering properties about them. And last time in Yokohama, we did have a discussion kind of about just the problem space for proxy discovery. And so this is just one proposal in that space. So I'd love to hear people's thoughts on this. All right. So there are a couple different use cases that this is trying to address that are all configuration discovery related. So the three different use cases that I'll walk through are a network provided proxy, and how do we discover if that is present? Think about, like WPAD and terrible things like that as existing practices where we have network provided proxies. But this is actually related. Earlier someone was bringing up at the mic line ATSSS, or cases where your carrier network may have a proxy that's trying to use for some purpose. Of course, through various 3GPP mechanisms that could be done, but that doesn't necessarily apply on other networks. And my perspective is that it would be nice to have an IETF standard across all different network types that would allow us to learn about the presence of a proxy that is on the network. The other case is discovering what proxies are related to a proxy you already know about. So maybe I know about just a plain old connect proxy, and I want to discover, does this support connect UDP and connect IP? Does it do other cool things or not? And then there's another use case of, can I learn something about what the proxy applies to? Like maybe this is an open-ended proxy that's been connected to the whole internet, or maybe it's very specific. And here there's a case for example, like in an enterprise type use case, we've seen there are now use cases where like Cisco and others are deploying like remote access solutions with MASQUE, essentially as like a VPN replacement. And in this case, you may want to dynamically know what things are accessible or other properties about this proxy, similar to what we do in IETF for learning about split DNS configurations. All right. So just to get some pictures up on here, here is kind of just a diagram of the network provided proxy. I'm talking to some servers, and the network has some proxy that I may or may not want to use. How do I know it's there? That is kind of one question we could help answer with this. We also have this case of I am configured with an HTTP proxy. Maybe I just had some old proxy configuration that just let me put in a proxy name and port, and I'm using HTTP Connect, and I want to say, does this thing support Connect UDP? Does it support Connect IP? Does it support Connect TCP, or some other variants and other URLs? How would I find those? And similarly, how would I discover that, this proxy is actually only good if you want to access these particular internal domains, and otherwise it's not going to let you get to things. So there are existing alternatives in this space, as I alluded to. Like there is WPAD and there are PAC files. So if you want to do DNS to your local network and get a JavaScript file and run that to figure out what proxy to use, you certainly can. But these are things that are not actually IETF standards. They require JavaScript parsing and running lots of fun code there, and they have a lot of potential security pitfalls. And also, they don't work with the current MASQUE proxies or other more URL-based proxies. that could be fixed. We could try to extend pack files to not just return a host name and port and know about connect UDP and connect IP, but I don't see that being particularly likely, and that seems like not necessarily the place where we want to invest. So I would like to avoid going down that road. So this document is talking about using provisioning domains. And so what is a provisioning domain? So this is one of the reasons why this initial draft was targeted at int area. So these PVDs came out of both the multiple interfaces MIF working group, but we also did a lot of work within int area to define them. So there's RFC 7556 that talks about provisioning domains as consistent sets of information. Think of just like, oh, it's your device's cell network configuration, your Wi-Fi network configuration, a VPN configuration. And RFC 8801 defined discovery of explicit PVDs that are named PVDs from a network. So a network could say, hey, this particular uplink has this named provisioning domain, and hey, it supports getting extra information from this JSON dictionary that's served up in HTTPS. And so that is one place we can hook into. So it defines, so think of the PVD as a definition of some JSON dictionary that defines a bunch of configuration about some particular network attachment. So what is a PVD? As I mentioned, it could be a particular uplink on your home Wi-Fi network. It could be your carrier network configuration. It can be a VPN. And it can also be a proxy, because when I'm going through a mask proxy, that mask proxy uplink is my tunnel. It is my provisioning domain. It's the way that I'm accessing different host names and all the different properties. So it too conceptually is a PVD and has PVD information associated with it, as a philosophical statement here. So practically, the document's doing two things. There are two mechanisms. So one is if you have this PVD JSON blob, it allows you to, like, there are a bunch of keys that the original RFC defined, and it just adds a key to say, here's a list of associated proxies that go along with this PVD. It's just an array of strings. And the other mechanism is allowing you to fetch this PVD JSON blob from a HTTP proxy. So like, how I actually fetch that thing instead of fetching it from what the network told me about. So pretty simple. So here's an example of the dictionary. Let's say I get this from the network, and it could list out a bunch of URLs of proxies that it's associated with. Now, one of the things here is that this is just defining a list of URLs, and it is, in this 0.0 version, having it be implicit what the type is. So like if you had a socks proxy, you would do socks : / whatever. And for the other types, you would infer it based on the URI template. So since Connect UDP has a particular URI template, if you see the variables that you use for Connect UDP, you'd be like, oh, look, this is a Connect UDP server. If you don't see it, you assume it's a normal Connect server. So this is one way of doing it. We certainly may want to have it be more explicit. You could have some nested dictionary format where you have a type explicitly saying, oh, this is a Connect UDP, this is a Connect IP, this is whatever other types. We'd need more of a registry or something then. So that's one point I'd like to get feedback on. And then for the other piece of the mechanism, PVDs already have their own media type. And when you're on a network, you just fetch them from a particular well-known based on the PVD ID. And so this is just applying that media type to say, if I do a get for the PVD media type to the URL of a known proxy, if it wants to respond by telling me this blob that tells me other associated proxies or the list of DNS zones that it's scoped to, it can return that to me. Otherwise, it won't if it doesn't support this. But this is something that if you had existing Connect proxies that wanted to add support for Connect UDP and other things, they could just respond to this get and then tell you, hey, come use all my other fancy new versions of proxies, and that's how you can bootstrap the upgrading there. For example, on split DNS, PVD's already defined a DNS zones array, and so the proposal here is just reuse that as if you want to specify specific internal domains that your proxy is associated with, set them, otherwise don't. And I think this just leads to the fact that this is a somewhat extensible dictionary where you could add more keys. So if we had other properties in the future where we wanted to say, oh yeah, you need this authentication, or maybe even for the, the ATSSS cases for 3GPP, they could put other keys in here to describe how you're supposed to use it for them. Like, this is one place where you could put that configuration information. All right, so these are generic slides. So like, this is something that maybe we want to target at int area, since it's really generic about how am I talking to networks about discovering my proxies. It is something that maybe we could talk about more in HTTP. Also, I think it's very relevant for this group to at least get the reviews and opinions of. I'd also be curious if anyone wants to do interrupt testing on either the network discovery or kind of the bootstrapping an existing proxy to learn about other capabilities. It'd be interesting. So yeah, feedback, thoughts, questions.
Hi, Mike Bishop, Akamai. Two things I wanted to comment on. First off, this is very similar to the draft that Ben Schwartz has presented the last couple IETFs.
It's spiritually in the same vein, but it's trying to use like the underlying PVD stuff.
Just maybe those proposals could be merged, because that's been looking for a home.
Yeah,
I think this is moving in the right direction, and it's an important problem. I'm really kind of leery of putting this at particularly the root resource with a different media type and trying to switch on that. I'd really prefer to see it at like a .well-known URI, but the overall structure I think is good.
Cool, that's good. And like, again, PVDs actually do have a well-known already allocated to them. So we could say, like, if you have an old Connect proxy, you just fetch it off of the well-known. Maybe that's good enough, and I'm totally happy to go that route. All right, who's next in queue?
I can't see from here. It's me. Hey, Lucas Pardew. So I think something like this, like config, is like just a no-brainer. We need to do it, because otherwise you're just kind of manually configuring things and out of band signals, and those are quite annoying. I haven't read the latest version of the spec, but something that came to mind is some of the difficulties I've had trying to configure my stuff is when I'm speaking to a proxy, sometimes they want some form of authentication, sometimes they don't, and I don't know if that was in scope for the config that you had, which made me wonder then when we have things like unprompted auth that you don't want to put those in. So maybe just, if there's nothing in the draft already, considerations to those effect could be useful, but that, doing that work in the working groups would help us have those discussions and figure it out.
Yeah, absolutely. This doesn't talk about authentication explicitly. However, as I mentioned, like, there's just like a blob of configuration. So if you would like to advertise to the world you need this authentication, someone could define a key that they put in that dictionary. And so that's either in this document, some other document. You can just register keys in the registry. It's already existing.
I want only one of these things to exist. So please don't do this in int area and have Ben go off and do it in privacy pass or whatever.
Yeah. Oh, you mean one configuration mechanism?
Let's not have that happen.
Totally agreed.
The other thing that I find is a little unclear in a lot of these things is that the trust relationship hasn't really been articulated particularly well. One of the things that I think has happened in the past that has been terrible in this particular area is that there would be an expectation that clients would stumble around the network and trip over one of these configuration files and then just use it.
Right.
And
absolutely terrible.
That has not worked out particularly well. And I'd rather not see that happen. So I think a little bit more thinking about how it is that the client is configured. I think Lucas's point about authentication credentials is a good one. They probably don't belong in here, but that means that there's something else that's floating around that is more than one piece of information. It's potentially multiple that says the identity of the thing that you're talking to, or the identity of the PVD in this case, credentials that you might use, and what you might trust that PVD to provide for you.
Yes.
And that is not a simple trust, not trust thing. It's nuanced. So
Agreed.
I don't know what to do with that. But having a clear sort of articulation of how you would use one of these things along those lines would be useful.
Yep, totally agree. And that's something that doesn't go into detail on now, but that's one of the reasons to have a clean break from PAC and WPAD and say, like, this is an opportunity to specify a better trust model.
David Skenazy, proxying enthusiast. This was short on time, +1 to everything MT just said. Let's do this in int area and bring in Ben.
Yep, great. Is Ben here? Oh, no, is Ben here?
Mia Kulivan, yeah, so that looks good to me. I have one question and then a comment. The question is, this is mainly focusing on, you already know that there's a proxy and you want additional information, right? Or do you also include the case where you actually want to find the proxy by getting information in your local provisioning domain about the proxy?
There's both. So in the case where you already know about a proxy, I think also the trust model is easier there, right? Like if I already trust this proxy for Connect and I just want to know, can I put UDP through it? That's not too big of a deal. And similarly, if I already say, I would be willing to send you everything under my, like corp.example.com, and you want to tell me that you want to take less of it, fine. Like, that's also an easy trust relationship. But then the other case is when that PVD comes from the network RA, then it's like, I didn't know about this before. And then the client has to decide, do I want to use this? And so there's a lot of different ways we could approach that of like, oh, I was expecting to find something here, or this is a PVD that's already on an approved list of ones that I trust, and therefore I can use it. But yes, this does cover the discovery from tabula rasa.
Okay, that's great. And then about int error, I guess we just recharted and we didn't include this one, but I also feel actually this is the right group to discuss this because we have the expertise about what we need, right? We bring it into int error, then we all have to go there as well or whatever. I don't know. So I'm not sure about this.
And so we should definitely have a discussion about the correct venue. I don't feel like it fits within MASQUE specifically because like even things like TCP proxying over HTTP, like Ben's draft, like that went into HTTP. That didn't even go here. Like our charter here is pretty narrow on like what's going through the proxy. And this is potential, like you could use this for SOCKS discovery, and like work on SOCKS has happened in int area as well. So it's quite fuzzy.
So our charter has a line in it that says discovery is explicitly not in scope, but we certainly are happy to run the chartering mechanism around as many times as we need. So in the interest of time, since we are past our time here, Carl, I saw you joined the queue after it was closed. Do you have something really fast to say? All good, cool. Next up we have Alejandro. We will come back around and I think we need to coordinate with Interi and some of the other groups to make sure that we find the right home for this, because there's definitely interest in doing this work. But as it stands right now, we said we wouldn't in MASQUE. So we need to figure out if we want to decide that we do or if we want somebody else to do it. All right, click the little slide button next to the hand up top. Yeah. All right, we'll go a little snappy if we can.
All right, I'm here to talk about a draft I've been working on for proxying Ethernet over HTTP, Connect Ethernet. There we go. We've already got stuff for layer 4. We've already got stuff for layer 3 in the pipeline. I figured, why not go deeper? So yeah, Connect Ethernet. I don't know if you've all read the draft. This is not the greatest response here. So why do we need Connect Ethernet? Because sometimes IP isn't enough. You want to do stuff with non-IP protocols. You want to bridge Ethernet segments. It's useful to have a layer 2 solution when you need it, and not use it when you don't, preferably. There are other things you could do, like nesting other layer 2 solutions inside of Connect Ethernet, but then you've got more loss of MTU, you've got more things to configure. So I figure it's a useful thing to have in the toolbox to have a layer 2 option available. How does it work? You take the Ethernet frames, you put it in the datagram. It's a lot like Connect IP, and it doesn't have any of the IP routing logic that is required for layer 3 stuff. So it actually is like a watered down layer 2, watered down Connect IP. And I landed one in Google's quiche. Sorry, Cloudflare. Yesterday. I've been toying with one for a month or two now and figured I should land it. So I did. I swear there are more slides. It's a 0-0 draft. There's plenty of work to be done on it. The question is there interest in doing that work? And like, yeah.
There, Chris Corla, I have no idea if there's interest, but just to be my usual broken record on this, there's been a lot of work on tunneling for Ethernet and other venues. I seem to remember reading some similar things when I was in the ISG. Has somebody like reviewed that material to make sure that like you've learned whatever lessons they had to teach, good or bad? If not, I would suggest it. I really have no opinion on the merits, but I'm just like, I know there's been a lot of work here, so like it'd be good to either explicitly accept or reject it. I think
I have certainly started reading through like the L2TP.
There's like PV3. It's like a pile of crap. I think.
Yeah.
Like, you know, I'm not sure if it's really good or not.
I have started reading them. I have not finished reading them.
Yeah.
But yes.
Okay. Yeah. Anyway, if there's, I mean, like, why not mask everything? But like, let's be
exactly
smart, right?
Marcus Ilar Eriksson. Yeah, I think there's definitely interest from us to adopt this. In fact, 3GPP are for release 19 discussing the potential of using ATSSS for Ethernet PDU sessions. So this proposal comes in very, very handy right now. So definitely, and I agree with Ecker, we need to do a lot of analysis for this.
Oh yeah.
Watson Lad, Akamai. I guess my main reaction to this draft is why? Just because you can do it doesn't necessarily mean it's a great idea. Is there like, is there like some pressing need to link up Ethernet segments? Like you have some ancient machine that can only talk to locally connected things. You want to expose it to the internet now? That doesn't really seem like necessarily a great idea.
Just out of curiosity, like Ethernet generally can't be routed, right? Like, what does this mean? That the mask proxy needs to be on the same Ethernet segment? This is the thing that you want to talk to by Ethernet? That seems kind of difficult to deploy, right? I mean, not impossible to deploy, I grant that, but kind of like reduces the scope.
Yeah. So, for example, I used this thing to bridge a box to my home Ethernet segment just this weekend. I'm not saying that this is something that everyone needs to be using all the time, but if you do need to do some sort of Ethernet bridging, if you need to do some sort of layer 2 solution for something, like then it's useful.
Mia Kulivan, just talking about the ATSSS use case. So their desire is just to have a generic solution that can kind of handle all kind of traffic rather than having specific solutions to like different kind of traffic, because that's like just a mechanism for providing additional connectivity in a mobile network. And so it has to be as generic as possible.
Hi, Alex Chernowski, Google. Once again, here to address Lorenzo's question. So I think that the deployment question is that this is a technology which is a little bit different than the rest of the Mask Connect family, because you're probably not going to be running a like industrial enterprise grade Ethernet proxy and then letting people connect to it. I actually see this as much more useful for if you are interested in enterprise use cases, things like when you want to have like a trusted top of rack router that needs to proxy DHCP and BootP for TFTP or something like that. So like I see this more as you want to bridge an Ethernet segment to something that's much more trustworthy and actually like have much more encryption on your network rather than having some of these legacy protocols that we use for bootstrapping and pixie booting and other things here. I mean, this is obviously also useful for the your Pixie device might not be able to do TLS, but your top of rack router over your WAN can certainly be encrypting your traffic. And like, I can tell you for certain at Google, we have had lots of pain and suffering doing NetBoot for our edge network, and having trusted VPN-like things that can do layer 3 has been a godsend, and I'm sure layer 2 will make it even easier. So I think there is actually a lot of use case here, and I'm very excited to see this work.
Is that me? Yeah, Marc Blanchet. I haven't read your document, but are you talking about multicast and broadcast kind of traffic and what needs to be done in this space?
There is a spot for it. I haven't dug into it. Mostly I have been receiving things over the quick tunnel and dropping them on a is it ton or tap? I always forget. Interface and letting the kernel deal. So there's probably some more work to be done there. Again, 0, 0.
Is that it? Yeah, you're all set. Thank you. So this draft showed up a little bit later than or right after the recharter was done, and unfortunately, we did not include this particular extension as one of the ones the working group would cover. Although after talking with Martin, our glorious AD, he said be willing to potentially do a quick recharter update if people did want to include this as a working group item. So just like the other drafts, I'm going to do a quick show of hands to see if there's interest in adopting this as a working group item under the assumption that we would be able to get the charter done quickly or updated quickly to include this in the list. So yeah, I'm going to run the show of hands now. Same exact question as before, if there's interest in adopting this as a working group item, assuming the charter accurately reflects that after the fact.
And if anybody is actively not raising their hand and would like to share with the group any of their thoughts or reasoning about that, you're more than welcome to do so. You can also happily anonymously not raise your hand. So.
Yeah, this one's less clear. Definitely gonna have to confirm the list, but I wonder if anyone who did explicitly not raise their hand in the show of hands wants to come to their mic and say why they don't think this is ready for adoption or is a good candidate for adoption. That could be quite useful. We definitely need some music during the show of hands as well. That would be great. Okay. Watson?
Watson, my reaction to draft is I just don't see a use case yet that justifies the investment at the time. I'm sure they're out there, but I just haven't heard one yet.
Sure. Lorenzo?
I'm not going to repeat what I said before. I just sort of as a general question, what's the cost of adopting this to the working group? Like if it's going to chew up resources, then that we should really consider carefully, right? You know, if it's going to take review bandwidth or whatever, if we can do this for free, Sure, but that's sort of that to me would be the main concern, right? Like there does seem to be concern about like limited applicability, but I think there it's like more like, okay, how much is this going to cost the working group?
Yeah, it's a good point, and it's one of the reasons why we only included 2 very explicit extensions in the charter right now, because we didn't want to burn the group with additional scope and like dilute our focus. So we'll definitely take that into consideration as we consider an adoption call. Yeah.
Eric Nygren, Akamai. I think it's like the concept is interesting. I think I agree on the understanding use cases, and it may be one where rather than rechartering, it may be worth having conversations with some of the other ADs like routing area to see if there's another place for this. Because like there's enough overlap here in the corner cases between things like EVPN and various and VXLAN and other things in that routing area space that we probably want to at least be coordinating with them closely if we're gonna do something here.
Coordination would make sense in that particular point. Yeah. Okay, I think in the interest of time, we'll move forward. Eric and I will talk, and we'll I guess we'll just maybe do an adoption call after the fact. Sorry. Oh, yeah, and Marcus, you are last up for sequence numbers.
All right, going to talk about sequence numbers. Done it a couple of times, so probably be a quite quick presentation this time. So we have talked about it. We talked about it last IETF. There are not many updates to this document, but pretty much just added a bit more background because that was pretty much lacking last time. So a little bit more description of what ATSSS is, and some motivation why there are use cases in ATSSS that require the use of something like sequence numbers. So a little bit of recap. This extension, we're just extending HTTP datagrams with adding a small field with a sequence number. Is intended to be used with 3GPP AT-SSS. In the specification of the AT-SSS, they define these datagram modes where you, so AT-SSS is a way where you split traffic over multiple accesses. You can do it in various ways. You have various steering modes. You can duplicate traffic. You can do bandwidth aggregation and such. When you do use some of these modes, you might want to have sequence numbers, and we define them as datagram modes in the specification. One datagram mode is without sequence numbers. One is with sequence numbers. So the wire format for this is not specified yet. The architecture is specified. So there is a document that can either specify the wire format for this or point to an IETF specification. It would be nice that we point to an IETF specification for this because it's an IETF protocol that we're modifying. So the idea is that this can be pretty useful for multipath proxy scenarios where the proxied payload is either duplicated over multiple paths. So you have a redundant steering mode where you kind of split the traffic, or you copy the copy the payload over multiple paths, and then you have to sort of deduplicate it on the other end. So kind of redundancy mode. And you also have the mode where you do kind of a load balancing. You're splitting the traffic over multiple paths, and then you want to sort of you have the risk of causing a lot of out of order delivery, and it can make sense to use some sort of sequence numbering to assist with getting the packets or the data back in order before forwarding it. So that's the use cases. And where did this thing end up now? Oh, maybe not. Oh, there we are. So we've had a student working on this. So we implemented this over a prototype of this sequence numbering over a mask proxy using multipath quick. And so we have a few very, very early results looking at like doing some reordering not for the duplication case, but for the traffic bandwidth aggregation case. And we just look at some measurement data on that. It's some very early measurements that this guy has done, and there will be more refined measurements and refined methodology. But what we have in place here is a very simple So we have a proxy running multipath quick. We have a very simple round robin scheduler. So we don't do any particularly smart scheduling here. Then we implement a small reordering buffer in the mask proxy with a static size. So you just define a number of packets. And then the end-to-end traffic is quick. That uses the very basic parameters from the RFC 9002 specification. Namely, we have a packet reordering threshold of 3 and a reordering time threshold of 9/8 of RTT, and we don't have any dynamic sizing of the reordering space. So it's kind of the bare minimum you do with Quick, and it also runs Reno congestion control, which is loss-based. So the emulation setup looks like this. We then have a we have a client that connects to a multipath proxy using mask, connects to an end server using Quick with these different delays, and then it uses a very basic scheduling approach then. It's a little bit slow. Okay, so some stuff we saw here. We have a very, very basic buffering scheme here. So we're not looking at delays and such. We're just looking at like static buffer sizes with packets. We're running at very, very low throughputs here as well. So just adding one more packet to this buffer queue makes a big difference. So what we're looking at here is the impact on goodput depending on the size of the buffer. So if we have 0 packets in the buffer, that's like the most extreme. And to the right, we have running everything encoded in streams instead of datagrams. And then we just look at the impact of goodput, and we see that, yeah, it starts leveling out at a buffer of around 10 packets here. So we see that there's, for this type of setup, there's some improvement by doing some buffering and doing some reordering in the proxy. Furthermore, we're looking at what's the impact on round trip times when doing this. So basically, we see that having this small reordering queues has a very small impact on the end-to-end round trip time that you see in the end-to-end connection. We do see when you start adding more and more packets in this buffer, it grows a lot. And when you run stream mode, it just explodes. But that's because when you're running stream mode, if you don't have any sort of back pressure in how you're writing data from the outer connection to the inner connection, you will just swamp up a lot of data in your proxy connection. And yeah, so you can do smarter things with the stream mode, of course. But we see that, yeah, you don't have much impact on the round trip time. Finally, we're looking at some congestion window plots here. So if you have a very if you have a very small buffer, it's a lot of stuff happening in there, but we see a lot of spurious loss events, like spurious loss detection due to a lot of out of ordering, and we see that the congestion window is continuously limited. We see that the outer connection is the limiting factor. The bigger the buffer we put, the better it becomes. We see fewer congestion events. We see fewer spurious loss events, and yeah, better utilization of the link.
Do you want me to help you out for a second? For the graphs, because there's always, for each of the scenarios, there's 2 graphs here showing either of the paths, right? So the green line is the end-to-end congestion window, the blue line is path 1, and the red line in the other graph is like path 2, basically. So what we see if we only have a buffer of 5 packets is that our end-to-end congestion window is limiting our throughput a lot, because we see so many reordering events. So the congestion window is just like very small. When we increase the buffer to 12 packets, it's still the same effect. We see a lot of reordering, but like it's just like less reordering, and so we can actually reach the capacity of the link nearly. And then at the very bottom at the right, we have the stream mode as comparison. That's the maximum we can reach in terms of throughput, basically.
And I mean, we have to keep in mind that this is a pretty naive implementation of the end-to-end quick. We're just doing the pure basics here. So there's a lot of congestion events due to treating the out-of-order packets as loss and then reducing your congestion window, and not like explicitly recovering from that when you detect that, or we don't even detect that there's spurious retransmissions and such. So there's a lot of stuff you can do on the end-to-end, but in the pure basics, yeah, we see that we have pretty big impact. Martin.
Can you go back to the last slide? No, apparently not. So
I'm trying.
The stream mode really destroyed that graph for me.
Yeah.
Because it's so
Yeah,
far out of whack.
Yes, you're right.
I think your claim about not increasing RTT is
I mean,
wrong.
You do increase it, right? But it's
30% is a lot. And so what we're talking about here is effectively ATSSSSS is I don't know how many there are. Is talking about a way to build a network that degrades performance pretty measurably here. And I'm not sure that I'm entirely happy about that. And I think just sort of glossing over that point is sort of not really very honest here. So sorry, but I think 20% at 10, which is the point at which you're talking about, is pretty significant.
Yeah, on the blue line, yeah, it's definitely significant. Yeah, we're focusing more on, yeah, for sure. It has an impact here, and I think again this is like very early results with a very basic scheduler, like pure round robin scheduler. For sure, you need to do better than this. That I fully agree.
We are over time, so Lars, if we can move through the queue, we're trying to leave time to drain the queue, but we are technically in negative time at this point. So, go.
Can I just explain the graph?
Very quickly.
So yes, we realized that we didn't display it very well, but it was too late to change it. But so the baseline is the 0 is like without any buffering, right? So you have to compare it to the 0, and then like you have to find the point of time where like you have the minimum buffer requirement. So for like the blue part, it's around like 4 or 5 packets where you want to configure your buffer. And for the orange one, where you have like a higher throughput link, you would go to like probably 10 or something.
Yeah.
So that's what you have to compare.
Yes, exactly. It's the difference between 0 and 10 here that we're looking at. So that the 0 is when, for the orange, right? So the 0 is the base case where you don't have any, you don't do any buffering at all. So,
Lars Eckert, so I think this is pretty bad, and it's even if you have very low bandwidth here, right? Because if you actually use useful bandwidth, you're going to need a whole bigger buffer, and your delay numbers are going to go up because they're proportional to the reorder buffer size, right? So if you use a gig, for example, instead of a meg, what would the numbers look like? And I think they would be looking pretty bad, right?
Nope.
like-
David's next in the queue. We have a queue. The
But-
queue
Yeah,
is closed.
so, I mean-
we are over
Answer to
time.
the question.
I
That's the
understand.
answer.
Yeah, but
Take it to the list, please. David, very briefly, we're going to run a quick show of hands, and then we're going to wrap up with Martin Duke.
Very briefly, this is a performance enhancing middle box. We've seen them in the past where back in 95, when you had a box that removed reordering, it actually improved performance because TCP stacks weren't smart. Today, our transport protocols, especially if you're using Quick is the best. Quick will handle reordering much better than handling delayed, like this delay that you're introducing to fix the reordering. So I think anytime you have a transfer protocol over this that's from this decade, this will make things worse instead of making things better. So I'm quite concerned about that.
Yeah, I mean, we see here we're running Quick here, and it's running with the base parameterization that you have from RFC 9002, and we do see the problems, right? So sure, you can do a lot smarter things on your endpoint.
All right, to wrap up here, just as a data point, we'd like to get a show of hands from folks in the room, and we can then use this to decide to take an adoption call to the list or have further discussion about what we want to do here. Click the raise hand or do not raise hand before you put your laptop away, and then start putting your laptop away, and Martin wants to wrap up with a few words.
Yes, thank you, Eric. Should I just go now?
Yes,
yeah, why don't I just go now? Yep. While you vote. Martin Duke, Transport Area Director. Just wanted to tell the community about a unfortunate scheduling conflict in this time slot at dispatch. Matt Jorish from Meta presented something called SAD CDN, which has nothing to do with content delivery networks. It is securing ancillary data for communicating with devices in the network. And he was very interested in having the MASQUE community attend that at dispatch, but we could not work out that scheduling conflict. So I invite you to go to the art area session, the dispatch session information, and either read the draft or watch the YouTube video of the meeting and comment and participate in it. Is there a side meeting too? Excellent. Okay, there's a side meeting tomorrow at 6. So look at the dispatch stuff and then go to the side meeting. Thank you.
Thank you all, and come grab some stickers.